Hello everyone, welcome back to my YouTube channel. Today we'll continue our topic that is laws of motion. So this is part 6 of the topic. In previous part we have completed the first law of motion. Today we'll continue and complete the second law and third law of motion. Let us start. Now we will discuss about momentum. What is exactly momentum? So momentum is defined as mass in motion. All objects have mass, so if an object is moving, then it has a momentum. It has its mass in motion. The amount of momentum that an object has is dependent upon two variables: how much the stuff is moving and how fast the stuff is moving. Okay, now the two variables are nothing but mass and velocity. In terms of equation, momentum of an object is equal to mass of the object times the velocity of the object. Now, momentum is nothing but product of mass and velocity. Every object has mass, and if the object is moving with a certain velocity, we term it as mass in motion, and that is nothing but momentum. And the product of mass of the object and with the velocity with which it is moving, it is nothing but momentum. In physics, the symbol for the quantity momentum is lowercase p. Thus, the above equation can be written as p is equal to m into v, where m is the mass and v is the velocity of the object. The equation illustrates that momentum is directly proportional to mass and directly proportional to velocity. So from this equation, we come to know that P is equal to m into v. So momentum of an object is directly proportional to mass. If the mass is greater, the momentum will be also greater. If velocity is greater, then momentum will also be greater, as mass and velocity are directly proportional to momentum. Let us see this. The effect of one object striking another object depends both on mass of the former object and its velocity. This means that effect of force depends on property related to both mass and velocity of striking object. This property was termed as momentum by Newton, and Newton's second law of motion tells you about the momentum. Okay, now let us learn some basic concept of momentum. So momentum has magnitude as well as direction. Now, how it has direction? Because it is a product of mass and velocity. Now, mass is a scalar quantity, but velocity is a vector quantity. So, momentum has direction of velocity. Since velocity is a vector quantity, it has direction. So, momentum also has magnitude and direction. Its direction is same as that of the velocity. In SI system, the unit of momentum is kilogram meter per second. Why kilogram meter per second? Because momentum is equal to mass multiplied by velocity. So for mass, we use kilogram. For velocity, we use meter per second. So for momentum, the overall unit becomes kilogram meter per second. While CGS unit system, it is gram centimeter per second. If an unbalanced force applied on an object causes change in velocity, then it is also cause change in momentum. The force necessary to cause a change in momentum object depends upon rate of change of momentum. In the first law of motion, we learned that when an unbalanced force acts on an object, the object changes its velocity. Now, when the object changes velocity, it will also change the momentum, because momentum is nothing but mass into velocity. If there is change in velocity, of course, the momentum is going to be changed. So therefore, the force necessary to cause a change in momentum of an object depends upon rate of change of momentum. Rate of change of momentum means rate means time. So change in momentum divided by time is rate of change of momentum. And the force which is causing the change in momentum, it depends upon the rate of change of momentum. Now let us solve a question related to momentum. The mass of cannon is 500 kg and it recoils with a speed of 0.25 meter per second. What is the momentum of the cannon? So what is the given thing? Given thing is mass is given 500 kg and velocity is given 0.25 meter per second. And we need to find the momentum. So we have discussed the formula for momentum. Momentum is nothing but product of mass and velocity. So momentum will be equal to 500 multiplied by 0.25. If you check the unit, it is kilogram and meter per second. Both are SI units. So if we shift the two decimals, so it will be 5 into 25. So these two decimals we have shifted here. So 25 into 5 will be 125, and the unit will be kilogram for mass, meter per second for velocity. So the unit becomes kilogram meter per second. So the answer is the momentum of the cannon is 125 kilogram meter per second. So I hope you understood how to solve problems related to this. Now let us discuss the statement of Newton's second law of motion. So Newton's second law of motion states that the rate of change of momentum is proportional to the applied force, and the change of momentum occurs in the direction of the force. Now when we apply force to an object, there is change in velocity. And when there is change in velocity, there is change in momentum. So the application of force and change in momentum, they are directly proportional to each other. More force is applied, then more will the change in momentum. If less force is applied, there will be less change in momentum. And the direction in which the force is applied, in that direction only the object will move. So the change in momentum will also be there in for that particular direction. So this is what the simple meaning of Newton's second law of motion. Now in Newton's second law of motion, we have a derivation where we have to prove that the force is directly proportional to mass and acceleration. So let us begin with that derivation. So when I will prove that derivation, we need to first write a description of the derivation. We need to first define the variables of the derivation. So let us start with the derivation. So here, first I will consider an object. So first point, consider an object of mass m. This is my first variable, that is mass m, having initial velocity u. This is my another variable, that is initial velocity u. Second point I'm writing. When a force F is applied, now I'm applying a force to that object. When a force F is applied in the direction of the velocity, then what happens? There is change in velocity and the object moves. So we can write its velocity becomes v. That is final velocity is v. So in these 2 points, we have described the three variables. First is the mass of the object, initial velocity u. Then we have discovered the force, and last we have discussed about the final velocity. So when I will apply force, the object will move with velocity v. Third point, or I will add here only, its velocity becomes v and the object moves for time t. So for time t. So for certain interval of time, I'm applying the force and its velocity becomes v. So we have here described the five variables, that is mass, initial velocity, force, final velocity, and time. Now we need to discuss about the momentum. So first there are also change in momentum. If change in momentum means we need to discuss about the initial momentum and final momentum. So the third point will be initial momentum of the body. So what will be the initial momentum of the body? What is momentum? It is product of mass and velocity. So when I say initial momentum of body, it means product of mass and initial velocity. Similarly, final momentum of body, will be mass of the body into final velocity, m into v. Initial momentum means we are multiplying the initial velocity. Final momentum means we are multiplying mass with final velocity. So here we got what is initial momentum and final momentum. Now we have to find the change in momentum. So what is change in momentum? Fourth point, change in momentum. Whenever I say change, change means final momentum minus initial momentum. So my final momentum is m into v minus initial momentum is m into u. So this is my change in momentum. Now we want fifth point will be rate of change of momentum. See how we have gone. We have first describe about the mass, initial velocity, force, final velocity, and time. Then we wrote the statement of initial velocity, initial momentum, and final momentum. Then we describe the change in momentum. Now we are going to describe rate of change of momentum. What is rate of change of momentum? Rate means per unit time. So change in momentum upon time will be rate of change of momentum. So fifth point, rate of change of momentum. So this is equal to change in momentum upon time. Now we have already found what is the change in momentum. So change in momentum is mv minus mu and time is t. So this will be my equation. If I simplify it further, what I will get? M common v minus u upon t. So I am getting m into v minus u upon t as rate of change of momentum. Let us go write the further steps. Now, rate of change of momentum writing in short form, it is equal to m into v minus u upon t. Now, if you just observe this, v minus u upon t. What is this v minus u upon t? We have learned in the previous class, previous lectures, that acceleration, that is a, is equal to change in velocity upon time. Change in velocity means final velocity minus initial velocity upon time. So we can replace this v minus u upon t with acceleration. So we will get, therefore, rate of change in momentum is equal to mass into acceleration. Why this acceleration came? Because acceleration is nothing but change in velocity upon time. So we have replaced v minus u upon t with acceleration. Now, this is our first equation, that rate of change in momentum is equal to m into a. Now, we will use Newton's second law of motion. So by Newton's second law of motion, by Newton's second law of motion, what second law of motion says? So Newton's second law of motion says that the rate of change of momentum is directly proportional to applied force, right? So we'll write rate of change of momentum is directly proportional to applied force. Now what is rate of change of momentum? It is equal to ma. So m into a is directly proportional to applied force, that is F. This is applied force. So ma is directly proportional to F. So I can write F is directly proportional to ma, and when we have to replace the proportionality symbol, so we put a constant. So we can write F is equal to K into ma. So where K is nothing but constant of proportionality. Now the value of K is 1 here. We have found that the value of K is 1. So we don't need to write the constant, so we can directly write it. F is equal to ma. So this is our equation. F is equal to ma. And from this equation, we can say that force is directly proportional to mass and force is directly proportional to acceleration. So I hope you got this derivation, how we have proved this derivation. So let us recall it again. First, we have considered an object of mass m, initial velocity u. When I apply force F to that object in the direction of velocity for time t, then the object starts moving with velocity v. Then we describe the initial and final momentum as m into u and m into v. Then we have to describe the change in momentum. Change in momentum is nothing but final minus initial. Then we describe the rate of change of momentum, that is change in momentum upon time. And there we have solved some steps. So mv minus mu upon t. Taking m common, we got m into v minus u upon t. Then v minus u upon t is nothing but change in velocity upon time. So we replaced v minus u upon t with acceleration. Finally, we got rate of change in momentum is mass into acceleration. Now, as per Newton's second law of motion, rate of change of momentum is directly proportional to force applied. So we can write F is directly proportional to ma. And to remove the proportionality symbol, we have to put a constant. So F is equal to k into ma. But the value of constant is 1. So we only write F is equal to ma. So this is the derivation for Newton's second law of motion. And from this derivation, we prove that force is directly proportional to mass and directly proportional to acceleration. So I hope you understood this. So in other words, what we can say, small force is equal to small acceleration. Now here is a truck. If you are applying a small force, it will accelerate with small acceleration. If you are applying a large force, it will accelerate with large acceleration. So this is what in simple words I can say. If the force is small, acceleration is small. If you are applying large force, there will be large acceleration. So force is directly proportional to acceleration. Now, acceleration is inversely proportional to mass of an object. Now, force is directly proportional to mass and acceleration. What about acceleration and mass? So, acceleration and mass, they are inversely proportional to each other. Okay. If mass is using the same amount of force, like for example, I am applying same force using the same amount of force. First case is large mass. If the mass is large, I'm applying some force, there is small acceleration. Second case, you can see the weight, the mass of the vehicle. In the first case, the mass of the vehicle is large. In the second case, the mass of the vehicle is small. But the force I'm applying is the same. For both the vehicles, the force I'm applying is the same. So in the first case, you can see that the mass is large, there will be small acceleration. And the second case, if I'm applying the same force as I've applied in the first, the mass of the vehicle is small, so it will travel or it will have a large acceleration. So acceleration and mass are inversely proportional. Force and mass are directly proportional. Force and acceleration are directly proportional. So larger the mass, smaller the acceleration. Smaller the mass, larger the acceleration. So I hope you got this. In SI system, the unit of force is Newton. The force necessary to cause an acceleration of 1 meter per second square in an object of mass 1 kg is called 1 Newton. Now here we have the definition of 1 Newton. What is 1 Newton force? So 1 Newton force is nothing but it is a force applied to an object so that the object will be accelerated with 1 meter per second square and the mass of the object will be 1 kg. If the mass of the object is 1 kg and it accelerates with 1 meter per second square, then the force applied to that object is nothing but 1 Newton. That's why we call 1 Newton as 1 kg into 1 meter per second square. So 1 Newton is equivalent to 1 kilogram meter per second square. In CJ system, the unit of force is dyne. The force necessary to cause an acceleration of 1 centimeter per second square in an object of mass 1 gram is called 1 dyne. Now, for example, if my object is mass is 1 gram And if I apply a force and it accelerate with 1 centimeter per second square, then the applied force is nothing but of 1 dyne. So 1 dyne is nothing but gram centimeter per second square. It is equivalent to gram centimeter per second square. So I hope you got what is the definition of 1 Newton and what is definition of 1 dyne. Now let us have a summary of second law of motion. So the acceleration of object is directly proportional to net force and inversely proportional to its mass. F is equal to ma, that is mass into acceleration. Acceleration is nothing but change in velocity upon time. Now we have a question related to second law of motion. An object of mass 16 kg is moving with an acceleration of 3 meter per second square. Calculate the applied force. If the same force is applied on an object of mass 24 kg, how much will be the acceleration? So there are two questions here. So we have first given the mass and acceleration, you have to calculate the force. So let us calculate. So given thing is mass, that is 16 kg, acceleration 3 meter per second square. We have to calculate the force. So what is our formula? Force is equal to mass into acceleration. So your mass is 16 and acceleration is 3. So 16 3s are 48. And what will the unit? It will be Newton. Because mass and acceleration is in SI system, kilogram meter per second square. You can write 48 kilogram meter per second square also, but this is nothing but 1 Newton. So 48 Newton. Now let us see the next part of the question. If the same force is applied on an object of mass 24 kg, how much will be the acceleration? So now we have found the force. So second part of the sum is same force is applied means the force which you have found in the first part, that is 48 Newton. So we have given the force 48 Newton and mass of the object is 24 kg. So what will be the acceleration? So again, we will use the same formula. Force is equal to mass into acceleration. So acceleration is equal to force divided by mass. So force is 48 upon mass is 24. So that is equal to, this is 24, 2s are 48. So acceleration will be 2 meter per second square. Now if you are confused in unit, how you can write? See, acceleration is force upon mass. What is force? Newton. Upon mass is kilogram. What is Newton? Kilogram meter per second square upon kilogram. So you can see this kilogram will get cancelled. The only thing remains is meter per second square. So unit of acceleration is meter per second square. So I hope you got how to solve the questions of second law of motion. Now let us learn about the third law of motion. So Newton's third law of motion states that every action force has equal and opposite reaction force, which act simultaneously. Now what is the meaning of this statement? So for every force acting on an object, there is an equal force acting in the opposite direction. Right now, I am sitting on a chair. So gravity is pulling me down in my seat. But Newton's third law says that the chair is also pushing me up against the equal force. So that is why I am not moving. I am sitting on the chair. So there is a balanced force. Gravity is also pulling me down and chair is also pushing me up. These forces are nothing but balanced force. They are equal force and acting oppositely. Now let us think upon this. Why does it hurt so much when you stub your toe? So when your toe exerts a force on the rock exerts an equal force back on your toe. That's why the harder you hit your toe against it, the more force the rock exerts back on your toe. And that's why you get more hurt to your toe. So our says toe is hitting on the rock and the reaction force given by the rock is because of which our toe gets hurt. So here also the Newton's third law of motion is used. Now see this. When you push on the wall also pushes on you. Now this man is pushing the wall, but the force is applying to push the wall, the same force is applied by the wall to him. So this is nothing but action force and reaction force. Similarly, you can see here example of tire and road. Now, tire and road are contacting with each other. So our action force become tire is pushing the road, reaction force become road is pushing the tire. Similarly, here gravitational force, earth is pulling the ball, reaction is ball is pulled by the earth. Rocket. Rocket pushes the gas, reaction is gas pushes the rocket. This is because rocket move in forward direction. So in every object, you can see there is an action force and a reaction force. Now there are some questions related to third law of motion. First question is a gun recoils, that is move backwards when a bullet is fired. So the backward movement of a gun is nothing but recoiling. So why the gun move backwards when we fired a bullet? What is the reason? So the reason is according to Newton's third law of motion, every action force has an equal and opposite reaction force. So when we fire a gun, when a gun fires a bullet, the gun puts a force on the bullet and the bullet moves in the forward direction. But the bullet exerts an equal force on the gun, and that's why the gun moves in the backward direction, as you can see in the picture. So when we fire a bullet from the gun, there is a force exerted on the bullet which is in the forward direction. But that bullet exerts same equal force. It exerts equal force on the gun, and that's why the gun moves in backward direction. So this is the reason for recoiling of gun. Next question is mechanism of firing of rocket. Now mechanism of rocket is also example of Newton's third law of motion. So basically what happens here, as you can see in the picture, force on the rocket, reaction, force on the gas, action. What is this? I will explain you. Now there is a fuel in the rocket, and when a chemical reaction takes place, then the fuel burns. And when the fuel burns, the gases, the exhaust gases, they escape with a great force. When there is a chemical reaction, there is a release of gases. So there is force on the gases and they exhaust. So they exhaust in the backward direction, as you can see in the picture. So this is force on the gases, which is our action. We are doing some chemical reaction. We are burning the fuel. So because of that, the gases are exhausted. So this is our action, and the gases moves or they exhaust in a backward direction. So these gases, what they do, they exert equal force and opposite in opposite direction. So you can see there is a force on the rocket which is exerted by these gases in opposite direction, and this force is also equal to the force which is exerted on the gases. So it exerts an equal and opposite reaction force on the rocket, due to which the rocket moves in a forward direction. And that's why our launching a rocket or mechanism of firing of rocket is based on Newton's third law of motion, as every action force has equal and opposite reaction force and they act simultaneously. So here our action force becomes the forces on the gas, and reaction force becomes the force on the rocket, which helps the rocket to move in the forward direction. I hope you understood today's session. We have completed with the second law of motion and third law of motion. And also we have completed with the practical day-to-day life examples. The next session will be the last session of the chapter, where we will learn about law of conservation of momentum. So if you found this video interesting, do like, share and subscribe our channel. Thank you.